Hi, hello everyone. I thought I'd give you a little bit of a guided tutorial of how to get onto the class OneNote page. I'm going to start by showing you what this will look like when you open it on your emails. So Tyler has very helpfully generated this screen capture for us. So he's logged on to connect, he's clicked his email, and you'll notice there's an email from me inviting you to join the class OneNote page. So then you need to just click open, and this will open the OneNote in your web browser, and it's linked to your school account, so you don't need to log in or anything like that. Tyler has also recommended that you bookmark this page, and I will suggest that you do the same. So whenever you feel like maths, you can come back and log right in straight away. So I'm going to show you what it looks like from my point of view when I log into to OneNote. The reason being that I'd like to encourage you to download the desktop version of the software, or at least the apps. The reason being that it just looks a little bit nicer, the ink comes through a little bit better than what it does if you look at it through the browser. The browser's completely fine, but you may wish for it to be a bit nicer, like I say. Okay, so we have recently been studying algebra, as you know, and at the section on the left-hand side, there's a tab dedicated to all the algebra notes. Within that, the first topic we did was language substitution and solving, so that's the first thing that comes up, so you can revisit that if you wish to. Factorizing that we did last week, another example. All of the notes that we have are there should you wish to review them at any time. What I'm going to focus on today is the questions that we're given for Puzzle City today. The reason being, it's just a handy little piece of revision. It's a handy way to showcase the way that this sort of video tutorial could work, and a few of the answers that were submitted on paper weren't quite correct, so maybe a good idea to correct some gaps before the test that's coming up. Right, so I've got OneNote in front of me, and one of the really cool things about it is that I can make, like if I get a request for a solution or something like that, if one of you says I'm having trouble with question 4 or whatever, I can just jump back into OneNote, add the answer in, don't need to address it to a particular student, I can just say, like, here's the answer that you were looking for. Anyway, in this case, the thing that you had to hand in was to come up with an expression for the area of the green part of shape A, as well as the area of this sort of L-shaped looking thing just there. So the actual measurement side of it is relatively easy, but putting it into algebra is the thing that makes it a little bit tricky. So using the browny, reddy, maroony sort of shape, if we were to work out the area of that particular L shape, the way that I would recommend that you do it, let's turn saving. Very good. The way that I would recommend that you do that is to find the area of this larger rectangle. So I'll just draw that in here. So find the area of whatever that rectangle is, and I'll just represent that with a big rectangle, but then I would take away this chunk that's missing here. So do it in a substitutive sort of way, like find the bigger area, take the smaller area away, and it will give you what's left. I'll represent that with another little rectangle there. So, area of the big rectangle, so this area just here. Remember, the area of a rectangle is length times width, so in this case, our length is going to be 5 lots of x, and our width is going to be the expression down here at the bottom, 6x plus 2. Cool, so that's our start. And then we're going to subtract the area of the second rectangle, which is this one just here again. Now this one's got a length of 1 lot of x, but again we need to multiply that by whatever the width is. And this requires you to do a little bit of detective work to figure out what that length actually is. So if all the way across here, as it shows you at the bottom of the diagram, if all of the way across is 6x plus 2, and between here and here is 2x, we can find out the distance between these two missing parts here by subtracting 2x from 6x plus 2, which will of course give us, I'll just write that in here, 6x plus 2 subtract 2x gives us 4x plus 2. This is a trap that a few of you fell into when you submitted your answers. You missed out some of you didn't include the 2, or some of you didn't subtract the like term quite correctly. So which is why we're doing this, I suppose. The other cool thing with OneNote is that we can go off the page if we need to. So if you're doing a solution that takes up a little bit more room, it doesn't matter as much as what it would do on a regular piece of paper, which I think is pretty cool. So for this smaller rectangle here, we've got a length of x and a width of 4x plus 2. Great. So the next step is to expand both of those brackets and then simplify by collecting like terms. So let's do this one in a little bit of red. So we've got to multiply 5x by 6x and multiply 5x by 2 as well. 5x times 6x is going to give us, well, the 5 times 6 component gives us 30, x times x gives us x squared, and then 5x times 2 gives us, well, we simplify by multiplying the numbers together, so 10x. The next part's a bit tricky, and I'll just do a little highlight there. Because we're subtracting everything that's in the next expression, it's the same as having a negative sign in front of the x. We've got to treat it as if it's a negative term, which I suppose it is. So first part to that is to do x, or negative x rather, multiplied by 4x, and x multiplied by 2. So when we expand that bracket, we'll get negative 4x squared for the first part, and negative 2x for the second part. Cool, so we're almost finished with this one. Now we've just got to collect like terms to finish up. That leaves us with 30x squared subtract 4x squared, which gives us 26x squared, and 10x subtract 2x, which is 8x. And that's it. So we can't simplify that any further because x squared and x are two different types of terms. We can only collect like terms together. And yeah, happy days. That's it. That leaves us with the second shape, which is actually a little bit easier. So if you followed the L shape, then that's great. Okay, so for this shape, it's a little bit different to the first one, where we've already got one complete shape here that we can start with. I'll just do the outline of that in green. But if we take away the orange area that's in or the area of the orange rectangle that's in the middle just here, it'll just leave us with the area that is green in this rectangle. So take the area of the whole thing, subtract what's orange, and you'll be left with what's green, as the famous expression goes. So area of the whole shape, that has a length of 5x, it has a width of 8x, and we're going to subtract from that the orange area, which has a length of x and a width of 2x. Cool, so you can see already this is going to be a little bit more simple, which I suppose is a good thing. So 5x times 8x, 5 times 8 gives you 40, x times x is x to the power 2. Subtract 2 times x, so minus 2x squared, and that simply leaves you with 38x squared. Cool, and that's it. So I'll leave it there because it's this is just a quick way to show you that this is the sort of thing that I can throw together relatively easily from my home office here in Leederville, where I happen to live. And if you like the format, we can do heaps more because they're relatively easy for me to throw together. But till then, email me any questions and see you tomorrow.